So let's look at an IP packet. Like, how does it break down? All right. I'm going to start with bit 0 on the left, and over here will be bit 31. Oops, 31, 32. So the first field in our thing is the version. Version, my goodness, I cannot write today. V-E-R-S-I-O-N. Okay, version. The version field is 4 bits. Okay. So first 4 bits of the 32 is the version. Right now this is set to 0, 1, 0, 0. And you all know your IP, or your binary math, right? 1's place, 2's place, 4's place, 8's place. We are in version 4, okay? IPv4, okay? We'll talk about IP version 6 in just a minute. Next up, there is a header length field. This is not a big deal. I'm going to skip it. That's another 4 bits long. There's some other stuff too. DIFF-SERV. That's actually 8 bits long, so I'll make it a little bigger. Then we have a length field. This is 16 bits. And that's how long the whole thing is going to be. Okay? The header has its own length. This is 4 bits. This is 8 bits. Okay? So just there's length. That's an exciting one. There is an identification. That's 16 bits long. By the way, until I put on something like this, it's not going to be on the exam. I just want you to know what this, you just want to hear it, right? The identification field, this will actually uniquely identify each packet. This is like I can put packets in order and do some other stuff. Okay. There's a little space here for flags. Don't worry about that. There's 3 bits there. What's that? This is something else too. I'm not going to worry about that either. Now we're getting to something useful though. Here we have the time to live. There are 8 bits here. And what this field does is we set as a sender, okay, the sender sets and the router decreases by 1. Okay, this time to live number. All right. So what happens with time to live is, so we'll start out, I think mine here is starting out at 60 maybe. I wonder what that is. Then every time it hits a router, the router takes off 1 number on it. When it hits 0, then the router returns an error. Okay, so that's when it tells you one of those errors of destination host unreachable. The idea here is we don't want to have packets that circulate endlessly. You guys remember our routing table, and we had all those entries, and then at the bottom there was the default router. So if we get to the bottom and we send it to the default router, and the next router doesn't know what to do with it, and it goes to its default, there's a potential for these packets to circulate endlessly. Okay? And we don't want that to happen. Now you guys have seen this actually used to find out something about the internet, and that is, if I set the time to live to 1, so I set the value here to 1, it goes out of my computer and the first router gets it, and it goes from 1 to 0, and then it sends me back an error. You guys see where that would happen? So I'll just write it here. So here's me. I set time to live equals 1. If I send the packet to my router, it will go down to 0 and it will return an error. Well, in that error, the router will give its IP address. So it'll say, hello, your destination was unreachable. Here's my IP address. If I set it equal to 2, do this one in red. If I set it equal to 2, I'm going to hop through that router. It'll go down to 1. It'll go to the next router down to 0. And then it will send me back an error. But what just happened there? With the time to live of 1, I learned that router's IP address. With the time to live of 2, I learned that router's IP address. And then eventually I'll end up with a list that looks like this. Okay? That'll show me every router along the way between me and the destination host. And all it's doing here is the first row is a time to live of 1. The second row meant a time to live of 2, and so it returned back the IP address of that router, so on and so on and so on. Isn't that fun? The other thing you might not have noticed here is the latency figures in there. That's all right. Okay? So time to live is how the trace route worked. That's how you got that. And of course, everyone in front of me is going, wow, I'm so glad you told us that. That was great. Now we know what's going on there. This other stuff I'm not going to get into. Flags, we got time to live. Oh. Next up over here is protocol. And normally here, we will flag things. There's 1 for ICMP. So the protocol equals 1 for like the ping messages or these error messages. It uses 6 for TCP, and it uses 17 for UDP. And we'll talk about why these are useful here, as it labels what's in that packet. But you can use these when you're doing your firewall to block certain kinds of traffic. And when we saw our Chinese thing, where's that? Where did that one go? There it is. So when we did our Chinese trace route and it had all these stars, that's because they're blocking ICMP packets going out. I think they are, yes. So they won't allow an ICMP packet to go out. Which is kind of funny because I could go into these people's website and get them going in. But, so there they can block that traffic. Okay. Then over here it has a checksum. This is going to be to check for errors. And still continues on. So if I got bit 0 still and bit 31. Next up comes the source IP address. That is going to be 32 bits. Then after that comes the destination. It is also 32 bits long. There's some other stuff in here. There's something happening. Oh, yeah, this person on the internet says, the same thing happened with some of the places I tried in America. You could find a route from it, but not to it. So if you all, as you all were doing it, you should have seen that kind of stuff. Just means they're blocking packets. People do get nervous sometimes about what goes in and out of their networks. Okay? And then finally here is data. So after that, and that's just ... Right? So we're used to this stuff, right? 32-bit IP addresses. And down here in the data, this might be a TCP segment. It might be a UDP, they call that a datagram. Or it might be an ICMP message. So like your ping message. Those would be in the data portion of your packet. Okay. So that one's fun. So again, this is IP version 4 packet. So there's a little bit of overhead here, right? So we got 32 bits, 32 bits, 32 bits, 32, 32, 32. Oops. That would be like right there. All right.